TTL Computer 2. Today we're going to take a look at using our testing jig to test our first computer board, which is our system clock. And the testing is really going to take two phases. First, we're going to do a low-speed manual test of the clock board using the testing jig, and then the second phase will be we'll put in the high-speed crystal and just look at the results on the oscilloscope again to see that the high-speed signals look good. Okay, so you can see. All right, we're just going to power this up. So you can see that we have power to our testing jig and we have power to our board with the power lights. And we also can see that we have an output here. So what I've got wired up here is that button 1 is wired up with the positive signal into our clock signal, oscillator clock signal pin, and that the switch 2 is our negative reset signal to the clock. And then I have the not clock, the P clock, the U clock, and the T clock wired up to our display, to our LED bar display. So it looks like we have our negative clock signal is negative state is active, and we can just clock this through, and we should see that these just, not clock, P clock, U clock, T clock. We should see that progression. And we do. Okay, so that's a good test, right? Cycling through the clocks, right? Not clock, P clock, U clock, and T clock. And then our reset of the circuit, clock circuit, should reset to the not clock state. And that's good. We're at the not clock state. P clock, U clock, T clock. Reset. So that looks good. So for our manual low-speed testing, the board validates good. So that's a significant milestone there. Okay, so I'm going to shut this down and wire this up with the high-speed oscillator, and then we'll take a look at the results with the oscilloscope. Okay, so I'm going to go handheld here for this next section. So I've got the high-speed oscillator is installed on the board now, and we can see that two of the signals are kind of solidly lit. That's because they're chugging along at 100 megahertz. The first two signals, not clock and P clock, I have hooked up to the oscillator, rather to the oscilloscope. And so we can see the oscilloscope is running, and I don't know if you can read that though, but we have the not clock and then the P clock following the not clock, and the oscilloscope has that at 1 megahertz, which is what we would expect to see, right? Because of our 4-phase clock. So each signal is operating at 1 megahertz. So that's the not clock and the P clock following the not clock as it should. I think I'm going to check the rest of the signals as well, just to confirm. And this is the P clock and the U clock signals. So again, those are following each other as they should. And again, that's showing 1 megahertz. And this is the U clock and the T clock. And again, following each other as they should. And then finally, this is the T clock and the not clock. So the not clock following the T clock. So that's a full cycle. Started out with not clock, P clock, U clock, T clock, and back to not clock again. So I think that's a good test, high-speed test of our circuit. Okay, so this concludes a successful low-speed manual test and a high-speed test for our first printed circuit board, our clock board, and also a good use, a good first use of our testing jig. And so this is just running in high-speed mode, and we can see that, I don't know if they're not bright enough for you to see, but the high-speed signals, not clock, P clock, U clock, and T clock are all on. So because they're cycling so fast at 1 megahertz, just look like they're on. But yeah, so this is a pretty significant milestone in our real physical realization of TTL Computer 2. So I do have to make some changes to our testing jig. I want to change these pull down resistors to get a little bit better responsiveness from the switches and cleaner switching in the signals. But we didn't really use those today in testing the clock board. But yeah, overall has the implementation so far has been going pretty well. I was pleased with the how the designs for the physical design for the PCB for the clock circuit and the testing jig came together. Pretty much how I envisioned they would be, but I did have some glitches with the testing jig. I have to change a couple of values. I have to change 2 values of resistors here in the testing jig, and I said I want to change the values of these pull downs, and I didn't unfortunately use sockets, so I'm going to have to desolder these things. But I don't expect it's going to be a big deal. But anyway, that's it for today. Significant milestone again in our testing and the realization of our PC boards for TTL Computer 2. So yeah, I think our next circuit PCB design that's going to be designed is going to be the program counter. And once we get that built and constructed and validated, it should be really quick to get the memory address register because it's virtually the same circuit, but it has a 16-bit output instead of the 8-bit outputs. So we should see some pretty quick progress on the next 2 boards. So that's it. Thanks for watching.